Flyzik.
Good afternoon and welcome to the show. During today's show, we'll discuss best practices with emerging technologies use in the federal government. More specifically, we'll be discussing security, geospatial, big data, virtualization, and mobility technologies. With me today on the show are Jerry Davis, the Chief Information Security Officer at VA, Joe Klimavicz, the Chief Information Officer at NOAA, Frank Konieczny, the Chief Technology Officer at the U.S. Air Force, Gary Newgaard, Director of Federal Programs at Isilon Systems, Marty RoesCH, the Chief Technology Officer at SourceFire, and Nick Combs, the Chief Technology Officer at EMC. We're talking emergency technology. Let's start with Jerry Davis, the Chief Information Security Officer at VA. Jerry, I know I've heard a lot about security trends and use of visualization capabilities at VA. Can you tell us a little bit about what you're doing in that area and some of the benefits you're seeing?
Yeah, so from a trending perspective, I think the number one trend has been, at least in my career in security, the last 15 or 20 years or so, the trend has been to be able to survive. More than anything, as survival has been the trend. But more than anything at VA today, we're looking at the big topics on our plate is around mobile device and mobile device security and application security. And then around where we've all heard for the last couple years or so, this aspect around continuous monitoring of your infrastructure and devices, and on a near real-time basis as much as you need to be. And then on the visualization side, we're doing a number of things, and that kind of ties into what I was talking about on the continuous monitoring side, being able to see everything that's on the network and being able to manage it in a near real-time environment. We're also using aspects of GIS for our business continuity activity, which we did at the last national level exercise with FEMA, where we're able to take GIS data and plot on mapping technology like a Google Earth type technology, and look and see where all our physical links were and how those links were impacted in the advent of, say, like the last exercise was an earthquake. Yeah. So we're able to plot it up on the map. We're able to do this for the Secretary, where we can actually see which near real time, which medical centers were affected by the earthquake, by seeing where the links were tied into the environment. Business continuity runs under my organization, so we're heavily investing in GIS technology. Going back to the mobile device side of the house, it's everywhere. It's proliferating all over the place. You know, my attitudes, people say, how do you deal with mobile devices in the environment? And I said, it's already here. It's not coming. It's already here. You got to deal with this. So I have a couple of different tenets about mobile devices or any device that comes into the network. Number one, I have to be able to see it on the network, and number two, I have to be able to manage it on the network. So we just recently, the CIO, Assistant Secretary Roger Baker, on October 1, put out a memo that we're going to allow a number of different technologies and platforms into the environment, things like iPads, iPhones,
I heard about that.
Into the environment, because the appetite for those devices in the on the clinician side of the house, the medical side of the house, is huge.
Yeah, I bet.
Great applications for medical use. The key is securing those devices. The big fear is losing data. So we took an approach that we don't allow data to ever reside on a device themselves. So what we're doing is we're implementing using things like virtualization on things like the iPad, for instance. So data is never resident or persistent on a device. We'll use something
so you
like,
don't have to worry about losing device.
Absolutely. So if you lose a device, nothing was ever resident on the device to begin with. So we're using virtualization and things like that, Citrix environments, and going over to things. It's working really well for us.
Sounds great. We'll drill down on some of these things as we move along. Joe Klimavicz over at NOAA. I'll change the topic here over to geospatial applications. We might as well get all the topics out on the table here, and then we can see if the panelists want to comment on each other on these various topics. When I think of NOAA, I think of just enormous amounts of satellite imagery and data and video and so forth. So I would think things like big data and geospatial and being able to crunch large amounts of data have to be a high priority for you. Can you tell us a little bit about how you're using some of these technologies and perhaps some of the benefits you see, Joe?
Well, absolutely. So first off, we're trying to deliver as much technology securely as possible. And one of the things we've really been focusing on is taking advantage of cloud solutions, cloud services. And we've got a whole host of things that we've been pushing to the cloud. But one of the things we've been trying to do is the geospatial services. We've been actually taking a very strong leadership role across the federal government and you might have seen an announcement that came out earlier about the geoplatform.gov in the cloud. And for the about a year ago, for the Deepwater Horizon, we actually hosted a early prototype of a geoplatform. It was actually hosted in our web cloud, an internal cloud that replicated in 6 or 7 different cities. But it's much more economical to take advantage of these public clouds. And so we've been working across the federal geospatial community to build essentially a cloud solution so that everybody can put their data up there. But beyond the shared platform, shared services, makes it easier for everybody to pull information. And we're providing these the data out as web services. So we're not inventing new technology or new software. We're just using what's available commercially. And we're using it in very innovative ways. But in addition to the shared platform, shared services, we're also seeing an incredible need for mobile application development. And everybody has the mobile devices, as Joe was talking about here. But we really need to push the geospatial capability down to these devices. And so we've built many different apps that run on mobile devices. And then another huge area is visualization, advanced visualization of geospatial capabilities. And we put some advanced visualization capabilities out on our websites. But we've also done something which seems to, it's just taken off like crazy, is Science on a Sphere. And we've got about 75 of these Science on a Spheres around the world. Yeah, and if you just check on the internet for that, type that in, and you'll come back with pictures of these essentially carbon globes hung from ceilings in different museums, different educational purposes.
Have to give that a try.
And so that's great. And you're absolutely right about the big data. What we've been trying to do is build integrated Earth system models that take into consideration a lot of very complex processes, ocean biogeochemical processes, and interactive atmospheric chemistry. We measure all these chemicals in the atmosphere, but we're still trying to understand how they interact and what they mean to weather and climate.
Wow.
And so we're building these huge mathematical models. And that's requiring an awful lot of supercomputing resources. And I've been focusing a lot on recapping our supercomputers over the last couple of years, research, development to operations. And so, my definition of big data is the data becomes so large, so complex, that you actually need a supercomputer to do the analysis. But the opportunities are tremendous because you're able to gain new insights and make better decisions.
Yeah, I'll tell you, the terms that evolve. Cloud came from, when we used to draw the internet, we drew a picture of a cloud, so then we called it the cloud computing. Big data is just lots of data, we'll call it big data. But Gary Newgaard, a veteran IT executive around town for quite some time. Tell us about Isilon Systems and what you're doing with big data trends and network attack storage to help government be successful and to help their programs move forward.
Well, good morning. Thank you. Good afternoon. I'm sorry. First, the thing that we're seeing from in the industry is big data is overcoming the past of columns and rows. Traditional data were structured data. So we're looking at the unstructured data for this year will pass the structured data and will continue at a compounded growth rate of about 67%. So every CIO, whether it's in the commercial or in government, is having to deal with this problem and trying to understand how can I scale out my storage in a predictable manner, in a cost-efficient manner. So just like in your personal life, you go back and you look at your computer and you say, well, what's on it? And now you've got images, you've got voice, video, you've got movies. So industry and government are in the same. And where we're seeing a tremendous trend is in particular in the life sciences, where we're doing genomic research. Each swab that you see on like an NCIS, well, that's a terabyte of data, and it doesn't take 13 seconds to get back and say it was you. So each one of these is a big data that has to be stored and look back, look forward. You see this in the cloud. You see this in defense and intel, and particularly in the ISR market, where we have unmanned aerial drones that are flying 24/7, and putting in large areas, looking for patterns of behavior, patterns of life in defense of the United States and our allies. Satellite data is streaming off the satellites all the time, and they don't want to just look at it once.
Right.
So what our customers and our business partners are looking for is, how can I solve this problem in a predictable manner? And how can I reduce the cost that I'm incurring to manage this? The GIS data, and how do you get that data quickly to the decision makers so that they can do interventions either in matters of national defense or humanitarian issues.
And how do you decide what the right data is? I know back in the reinventing government days, we used to see all this data being collected, and the agency may only be using like 5% of it, and the other 95% would be tremendously useful to someone else, but we didn't have the ability to get it to them.
Right, and you can't just go pull a tape off the shelf anymore, so people want it real time.
Yeah,
so
we live in
it's an exciting part of the business right now.
Yeah, we're approaching a time when, an era where time equals zero when it comes to decision making. Decisions have to be made instantaneously.
You want it now.
So we need everything that the three of you already said. We need security on that end device so we can get the information there. We need the visualization and the geospatial stuff to get there. And we need the big data crunching to get the right data there. So you're right. These are key technologies. Let's go to Frank Konieczny, the Chief Technology Officer at U.S. Air Force. Frank, I know you're doing a lot in enterprise virtualization and a lot with mobility trends. Can you talk a little bit about some of the things you're doing and the benefits you see that you're accruing at the Air Force?
Sure. Just like the other panel members have already talked about, virtualization is a big deal, as well as big data, as well as security. I mean, in the Air Force, we've taken several surveys of what's going on. We had a Gartner report done, as well as an IBM analysis done, as well as the best way to do virtualization. We also have research being done by Air Force Research Labs in terms of resiliency of the cloud, how you do a resilient cloud, how you do a secure cloud, how you do a cloud that has multiple level security attached to it. Because those are some of the problems that we have in the Air Force, is how am I going to support various levels of security at the same time in a cloud environment. On top of that, we've started planning towards it. We've gone to web services for a lot of the applications, which is what everybody does and what you need to do for virtualization. We've done a attribute-based access control system to actually support that, as well as doing the metadata tagging. Like we talked about the ISR videos and things. We have to tag everything. And we're getting to the point where we're tagging all data, so we get more instantaneous response time back. Now, operational-wise, as we do data center consolidation, we are moving into a virtualized environment for most of that. Sometimes it's difficult to determine what should be actually virtualized, and that's one of the issues that we have, is that as we go through the asset inventory, is this a good candidate or is this not a good candidate? Obviously, remote piloted vehicles controls are not a good candidate for the cloud. But, you know, normal websites that are open to everybody, well, sure, that should be in the cloud anyways. And so we're looking at that and doing that analysis, is what is the best fit to move things into the cloud. One success story we could talk about is that we actually have a software as a service that we've done for the Personnel Center, Personnel Operations Center. Their customer relationship management system is in a software as a service entity in the Dec. Surprisingly, the Dec, yes. And we're actually reaping benefits from it. We saved cost avoidance of $12 million over the FIDUP, as well as we saved about $2 million, plus $2 million in just licenses and personnel costs that we had. So as we see the trend going that way, is to find the right applications to move into the cloud, we can actually reap benefits from it.
So you're improving business processes, streamlining, and also reducing costs. So you're achieving benefits right across the board.
That's right.
That's great. Marty RoesCH, over at Sourcefire as the Chief Technology Officer. Tell us a little bit about some of the next generation intrusion protection. I know you guys are doing a lot in the cybersecurity field. Tell us a little bit about some of the things you're doing to help government solve some of these problems that we just heard about from some of our government guests here.
Well, the government is a very interesting customer of ours because they have a lot of very unique problems. They have very large networks with many, many users, something like on the order of 15,000 networks with over 7 million endpoints in them. So from our standpoint, this is a big target that's under constant attack, and we need good tools for being able to protect it. So you have a network environment that looks like that. That's also extremely dynamic. You can have SATCOM networks that can be stood up and torn down within minutes or hours, and this presents challenges when we're deploying security technologies that are traditionally structured around the concept of static networks. If you look at many of the security vendors that are out there, they built their technologies around the idea of enterprises that are relatively static. Now we have virtualization and mobile happening now, which means even enterprise networks are becoming fairly dynamic, but nothing like what you see in government networks. So what we're doing is we're working on trying to solve the problems that they have today. We see a big problem with advanced malware, this malware that gets into environments and is very difficult to get out. We saw this with recently in the news, a UAV command and control structure got infected with some viruses, and we saw this. One of the quotes I saw was saying, it keeps popping up. We keep trying to eliminate it, and it keeps coming back. That's the definition almost of advanced malware. So we're coming up with tools to be able to combat that. We are leveraging big data. We are leveraging the cloud to be able to detect novel malware that's being introduced into environments, being able to trace the file trajectory of these pieces of malware so that we can actually get back to the root cause of them and eliminate them throughout the environment. We can also see their communication structure by monitoring the network environment. So we are working on that. We also have our next generation intrusion prevention and firewalling technologies, which are aware of the networks that they're embedded within and are capable of seeing change in those environments in real time, and then taking that information and turning it into real-time defense of the network environment.
Yeah, terrific. I guess it's with all these emerging technologies, staying proactive and out in front of them becomes a big challenge.
It definitely is. With the ways that the attackers operate these days, they are very dynamic, they are very motivated, and quite frankly, they're very well funded, which means that we all have a very large problem to solve, and especially when we have expectations on the part of our employees or our users of our network environments who, you're deployed in the field and you want to use Facebook to stay in touch with your family. Well, I need to be able to control the applications that are being used effectively in order to maintain operational security. If I upload a picture that's tagged with geospatial data that says right where that Humvee is, that's not a good thing. So I need to be able to control those sorts of things. I need to also be able to control the flow of information for things if someone is injured or killed, so that the family is informed before the rest of the world knows, things like that. So having a very fine application control is very important as well, and that's another thing that Sourcefire has been working on. Yeah,
terrific. Sounds great. And Nick, I want to hear from you on this one too, but first we're going to take a very short break. You're listening to the Federal Executive Forum on Federal News Radio, 1500 AM. Welcome back to the Federal Executive Forum on Federal News Radio, 1500 AM. I'm Jim Flyzik here with Jerry Davis from VA, Joe Klimavicz from NOAA, Frank Konieczny from U.S. Air Force, Gary Newgaard from Isilon Systems, Marty RoesCH from Sourcefire, and Nick Combs from EMC. We're talking emerging technologies. When we went to break, we haven't heard from Nick yet a little bit. So I'm going to start with you, Nick, on when I think of EMC, I think of storage, I think of cloud computing, things along those natures. What are you doing to position to help government be successful in those areas?
Well, thank you, Jim. There's a lot being done around those two areas, and we've been investing in virtualization for years, really starting back with our acquisition of VMware in 2004. But virtualization is not a new concept. It was around in the mainframes back in the 60s. What we've done today is really brought it into commodity components. But it is really the allowing a tectonic shift in the IT industry. And it's not all the talk around virtualization has really been mainly around server virtualization, but virtualization across the technology stack is where the real innovation is going to take place over the next few years. And storage virtualization in particular has been around for years, but primarily as tools to migrate data. It's really not been used in large-scale enterprise in the past. But that is changing, and we are working with some of the national laboratories, some of the government agencies to how do you get distributed cache coherency. And this is really changing the COOP. So storage virtualization of the future is really going to change the COOP plans for our agencies. How do we have active data centers to where you're no longer having to back up your data? You have dynamic information flows across the planet, and that can be done today. Another term around that's really changing in the virtualization space is information lifecycle management. Another term been around for years.
Right.
How do you manage data at large scale? In the past, it's been very complex to do that. Well, we're actually building those automated capabilities into the technology itself. So in the past, when you'd build an Exchange server, you talked about it, Jim, most of that data wasn't even used.
Right.
Yet it was sitting on very high cost storage and taking up a lot of power and space. Well, technology exists now to automatically move that data down the tiers of storage.
Right.
And you're no longer having
just the persistent data, or data you're using all the time, is ready and available, and the other data can be pushed back to other devices.
to lower cost devices. It's allowing us to deal with this exploding digital universe that we have. And around cloud, I think we'll all be happy in the IT industry when this buzz around cloud dies down and the hype cycle goes away.
Yeah, well, we'll see. You know, we've done a number of shows on that too. You know, I just hope we get the money to do the data center consolidations to lead the cloud. You know, and to be able to do virtualization and add all these emerging technologies. It would be very disappointing to move all the old stuff as is to the new locations.
Absolutely. And, you know, and there's a type for all types of clouds, public, private, federated clouds. And really, the deterministic is around the security and the sensitivity of the data that really needs to be put out there. But every single IT organization and IT system that's out there can benefit from what cloud brings, flexibility, dynamic, efficient IT. So we really need to take a look at how and where we can put our information and leverage the clouds that are out there and the capabilities that industry is bringing.
Yeah, well said. I think, you know, and I say this all the time, we got to get it done before our kids get older, because they're going to expect to just grab things whenever they need them, as opposed to the way we do things today. Let's shift and let's talk a little bit about some of the difficult challenges with some of these technologies and some of the things that you still need to get done in order to get where you're trying to go. Let's start with Joe Klimavicz at NOAA. Joe, what are some of the things that are still, you know, difficult to do with all this big data and the geospatial stuff you're doing? What are some of the challenges you face every day that you're trying to overcome to get where you want to go?
We talked a lot about cloud computing and mobile devices, and while they bring great opportunity, they also do bring significant challenges.
Sure.
In NOAA, we're looking at a tenfold increase in data volumes, data growth by 2020. And it's not only just the data growth, but the data size of the data sets. So and so very significant growth in data, size of the data sets, and absolute quantity. We're very concerned about data preservation. We keep our data forever in long-term archives. Data access, dissemination, usability, those are huge issues for us. And there's a lot of research going into how do you automate the analysis, different techniques, data mining, machine learning. Privacy is a huge issue when you keep all this information around for a long time. Database interoperability is a big challenge. One of the interesting things that I don't think we've got much press on is the trade-off between storage and computing. So we don't have an endless amount of compute or storage. So we're having to, some of our scientists are having to look at how much do we actually save and store versus how much do we recreate using computing capabilities. So that's a trade that we're making on a regular basis. Security, as everybody knows, is a huge challenge.
Yeah, I think that's a challenge right across the board.
I'm not going to spend much time in that, but how we integrate cloud solutions with our existing security operations is something that we're finding needs to continue to mature.
Sure.
Because we have a lot of capabilities in place. We have a lot of mandates, federal mandates we're implementing. The network capacity, as we try to move large data sets, we're spending a lot of time, effort, and money into improving our network capacity.
Right.
In NOAA, we've got hundreds and hundreds of sites across the country, and if we really want to take advantage of these capabilities at all these sites, we need to
move that data.
Got to move it. there's a lot of contractual issues, especially with cloud and terms of service agreements, and when the data's out there.
That's another one on cloud. We had that discussion too. Cloud's going to change that acquisition model quite a bit, and it's going to be a real culture challenge.
It is. And then, we talked a lot about mobile devices, but I think just the sheer number of devices, the fact that they're changing so rapidly, it's very hard to get a handle on these devices. Every 18 months, new ones are coming in the market. They seem to be targeted more for consumers versus the enterprise. Right. What's a personal use device, government use device? How do we want to move forward on that? Remote management of and making sure that your data, as Jerry talked about earlier, is making sure your data is secure and you have control of it at all times. And I think lastly, we talk about the cloud solutions of shared services. I think there's a lot of governance that we still need to tease out in terms of managing risk, because if everybody's going to be dependent on these shared services, they have to be there. And then lastly, the whole funding and how we actually charge for these shared services.
Money is always an interesting thing. So I'm sure when you have your components together, they don't all just say, "Oh boy, I'll pay X amount." I'm sure you have some discussions. We'll hopefully have a little time to talk about that as we move along here. Let's go to Frank Konieczny over at Air Force. What are some of the big challenges that you see, Frank, as you move along with your virtualization and all these mobility trends?
Obviously, it's the large data sets. I mean, we have a lot of ISR data sets as well. In fact, we're going towards probably a storage as a service solution for a lot of those, because we have to have distribution points where you push out everybody. The acquisition cycle is always a problem. I mean, we don't really have easy ways to acquiring clouds right now. We've gone towards a DISA-first philosophy where we're like DISA to support us as a cloud broker or whatever to get the secure cloud that we need. We also have the SLA issue. I think everybody has that SLA issue and how to define the SLA. That makes sense for us, because if we have mission-critical apps, giving us money back is not going to help us achieve the mission. And then the other side is the mobility side. I mean, we have airmen coming in and they're used to mobility. My children are very used to mobility, and they can't live without their cell phones and whatever.
Absolutely.
And the same thing with the new airmen. They can't live without their cell phones, but we have no way right now of bringing in like pads and whatever. We have a pilot right now for a pad, but the secure technical instructions has not been approved yet for the pads or for any of those devices. And so we're in a security dilemma, if you will. We want to have the devices, the mobility, but we have to figure out how we can secure them. And I let people have the same issue with security. We have an issue with, sometimes we want to have, we always talk about dual persona devices, where we have apps that come down that are like, restaurants and navigation, which come down normally, on any pad that you have. But we don't want to have a special DoD store for just those. Why have a special, or do the same thing over again?
Mobility is a big topic here today, and I was talking to some people doing some research on some devices, which seemed pretty cool to me, where they could put business applications and then firewall in the device off the serendipity stuff, so your personal stuff and your business stuff, and they have it so that the business stuff only works with when you are able to log into the network and things like that. So if you lose the device, no one would be able to use the business stuff. So that stuff's coming, and I think the whole market knows that issue's got to be resolved somewhere down the road.
They're working at it. They're working at sandboxing different things and security-wise.
Absolutely. To Jerry Davis, a number of these issues you already teed up in the very first answer, but what do you see as some of the big challenges and constraints and things that you really need to overcome to get where you want to go with some of these technologies?
As Frank I see kind of a common thing going on here, and as Frank just kind of mentioned, for me, on the security side of the house, and it's around managing large sets of data. So if I just kind of throw some numbers at the VA environment, consolidated, centralized, which is nice from a security perspective. But I'm still trying to manage 380,000 desktops, security for that, 40,000 laptops, 18,000 mobile devices, 21,000 servers, and about 15,000 network devices. And then we're talking about 250 to 400 terabytes a week of data traversing our backbone. There's a lot of information in there, or a lot of data in there. How do I take that data from a security perspective and turn it into usable information. So I have to be able to collect it and distill it down to something in a near real-time environment.
Wow.
So our challenge right now that we're really starting to dive into on a security side of the house is how we're dealing with big data analytics.
Right.
I'm going to go and dig it up somewhere, but I remember saying about 3 or 4 years ago at another organization that we're getting to the point on the security side where we need so much data to be able to prevent and detect attacks that I'm going to need supercomputing-like resources to be able to crunch all this information. And I'm finding that it's becoming very true. With all this data that's coming up, I got to turn it into some usable information that allows us to act very rapidly. For me, on the security side of the house, it's all about getting my mean time to detection down very, very small, so we can detect and then react very, very quick to the issues at hand. The other side of that is storage. What we're finding when we go back and we've had an incident of some type and you go back and you do post-mortem, you realize that, I wish I had 3 years of logs or 4 years of logs and that sort of information. So storage and then the analytics to pull the data in from different sources, unstructured data, into something that's usable information is a huge challenge for us. Again, not just IT management, but we're finding on the security side as well.
Yeah, great. I know we had a discussion about cloud and data centers and all. On the security, the feeling was, to date, we've been very reactive. Something breaks, we fix it. Something breaks, we fix it. Bad software, we patch it, et cetera, et cetera. And over time, we have so many fixes in place now that there's Band-Aids everywhere. One thing about cloud, it does give you a chance to maybe step back and say, do we need all these Band-Aids, or is there a more holistic approach? So it sounds like the kind of things you're doing. Let's go to Nick Combs on challenges. Now, I guess, hearing from Joe Klimavicz, said they save all this massive amounts of data forever, and Jerry, with the numbers he just rolled off, I guess that's not a bad problem for EMC or Isilon, as a matter of fact, but what are some of the challenges you face in order to be able to support some of these obviously massive challenges that these guys have?
I think it is a challenge for us, and it's a challenge for the IT industry. And let me put it into perspective, the information at scale that we're talking about, because when we talk about big data, when we talk about the exploding digital universe and what's taken place, no one in industry has this problem solved. And I'll tell you some of the things that we're doing. But first, I'd like to put it into perspective. We talk about a petabyte of data. We talk about gigabytes of data. If a byte of data was a grain of sand, a petabyte of data would be all the sand in a beach, 100 yards wide, 1 foot deep, and a mile long. It's not a needle in a haystack problem. It's a massive information challenge that's taking place. Roadrunner at Los Alamos became the first machine to become petaflop in 2008. By 2018, we're going to be facing exascale architectures. And think about an exabyte of data. That's all the sand in a beach the entire length of the coast of the United States.
Wow. So,
and then if you think about networks to support it, you can multiply that times 8 because there's 8 bits in a byte. So the information challenge, I believe, is the number one challenge facing the IT industry. Well, what we did, and just recently, and it'll be announced, a press release next week, but we also pre-announced it at the supercomputers, we started a research and development, cooperative research and development agreement with Los Alamos. So how do you get to exascale architectures? So in 2018, we're hoping to be back on top of the world with the fastest supercomputer. But how do we deal with an exabyte of data? That's yet to be determined. But those challenges are being worked in the research industry.
Terrific. It's going to be interesting to watch how this all falls out. Gary Newgaard, how about Isilon? What are some of the challenges you see to try to help these government executives achieve their mission and get to where they want to go?
So I think one of the challenges that has been kind of understated in this conversation is the cost of managing the infrastructure. So the customer sets that we're working with are looking for predictable, scalable cost. I want to know I can push a button on an Isilon and in 60 seconds have another 100 terabytes available to me. That's simple. I don't need the cast of Ben-Hur to operate it. I need a few talented people. We have customers that have gone from a few terabytes to 15 petabytes. And their cost to maintain that, they do with 2 to 3 people.
Yeah, I think that's very important. I think you're on to something really important here.
So in the environment that the government's operating in now with reduced budgets, cutting costs, I was at GeoInt, and the primary message there is that everybody's going to give at the office, whether it's the people that are doing operations and management, the integrator community, everybody's got to give. So the customers are looking for, how do I reduce my footprint? How do I get a green footprint? How do I get a predictable model that I don't have to add 3 more people every time I add another 100 terabytes? And that's what Isilon provides to our customer set, is that we can literally go from 4 terabytes to 15 petabytes and 144 nodes and operate it with 3-4 people. And that is a model that works in a green environment. We have customers that don't allow anything to come in unless something goes out. They measure it by the watt, they measure it by the pound, they measure it by the number of people that it takes to operate. And we've had customers go from 3 racks down to 1/3 of a rack of Isilon.
Wow.
And they go, wow, just like you just said.
Well, I think that's what's going to happen in order to manage just what's happening. Marty RoesCH, how about over at SourceFire? What are some of the challenges you're trying to overcome to help your government customers be successful?
Well, we have kind of 2 classes of challenges that we're really interested in at SourceFire. First off, we have the nature of the attackers themselves. I think 2 good words to describe the attackers that are out there today are innovative and relentless. Relentless is actually kind of a big deal because, hackers don't need to beat the Beltway rush. Hackers have all day and all night, and they don't have to stop. They can stay wherever they are and keep going until they hit their conditions of success. So that's really interesting from the standpoint of kind of almost having an asymmetric warfare kind of thing going on. They don't have shifts. They don't take off and hand it off to the next guy.
Right.
So you've got that going on, and because of that, they tend to be extremely innovative. When they run into a roadblock, they don't just try to outmaneuver it. They come up with entirely new ways to attack the problems. So this leads to the kind of environment that we have today. We saw there was a report out. We saw 286 million new variants of malware last year. We know from the data that we've got from our cloud-based detection mechanisms that 75% of the malware that we see is unique. It's seen exactly once. And the average lifetime of a piece of malware is 6 hours. Well, think about that from the standpoint of I'm trying to come up with anti-malware systems that are signature-based. In other words, I need to write signatures to detect the malware, but how am I going to write signatures for 286 million things that are only going to be seen once?
Right. Interesting challenge.
Right. So we need to come up with methods that allow us to detect malware without having to actually know what the malware is ahead of time.
Almost like Gary's analogy with Isilon, having to find ways to use the technology as opposed to people to try to sort through those massive amounts of data.
Exactly. So we're using big data mining techniques to be able to look at the execution footprint across millions of desktops and being able to see what is unique, what doesn't belong here, which of these things is not like the other. So we're doing those sorts of things, and we're also having to deal with the enterprise scalability side of things, coming up with performance, coming up with effective detection methodologies that can run on these mobile devices that can operate in cloud and virtual environments that are as dynamic as the environments that they're protecting, because if you don't have dynamic defenses, you're going to have trouble in the environments that we're in today because, quite frankly, the networks are changing too rapidly to be defended like the Great Wall of China. It's just not doable.
Absolutely. Thanks. That's great analogies there too. We need to talk a little bit about governance, and then we're going to shift and talk about the future. But first, we're going to take a short break. You're listening to the Federal Executive Forum on Federal News Radio 1500 AM. To the Federal Executive Forum on Federal News Radio 1500 AM. I'm Jim Flyzik here with Jerry Davis from VA, Joe Klimavicz from NOAA, Frank Konieczny from U.S. Air Force, Gary Newgaard from Isilon, Martin RoesCH from SourceFire, and Nick Combs from EMC. We're talking emerging technologies. When we talked about the challenges, constraints, we talked about benefits. Let's talk about governance for managing all this stuff. Let's start this time with Frank of Air Force. It seems to me, how do you decide, make some decisions? Is there some structure in place to decide which technologies and which products? How does that all work?
Sure. In the Air Force, what I'm in charge of is developing a technical baseline for all the IT functions within the Air Force. And that is the governance we're going to go forward with. And we determine this based on the enterprise architecture where we derive the functions from. But going forward, we have various integrated product teams across the Air Force that come together to work on what technologies you want to go forward with in the future. And then we determine the specifications, what we want to see in the future, and those are the ones that are required to be implemented.
Right. Okay. Terrific. What about you, Jerry, at VA? VA is a big place. So I'm guessing there's quite a few people there that might have an opinion about what you want to do or not do, or which products and so forth. And how do you actually, come to some agreement as to which direction and which products you want to run with?
Right. So under the CIO's organization, there's obviously a number of functional pillars that are involved in our governance process, like EA. So we have some basic underlying framework around technical reference models and things like that. For me, it's all about risk management, right? So I make governance decisions based on the amount of risk that I can buy down, the amount of risk I can transfer, avoid, or whatever. So we make decisions on whether it's technology purchases or if it's policy implementation, policy changes, based on the amount of risk that we can buy down. And it doesn't always, the risk management schema doesn't always mean that we have to buy something new. It may mean that we just have to change the way we do processes and things of that nature. So I came up in risk management. It seems to work for me very, very well. And that's kind of the governance model that we use. Everything is driven by risk and our tolerance for risk.
Yeah, that's well put, because we've had discussions quite a bit. The term risk management resonates a lot better at the senior level than information security.
Sure.
If you talk information security, it's sort of, but if you talk managing risk and talk about some of the things that can happen if we don't secure our systems, it becomes a different set of issues. Joe Klimavicz, how about you in terms of decision-making processes to decide which technologies to implement, which ones, which product sets maybe to go with? Is there a process in place?
Well, we have a very mature decision-making process in NOAA. We have a NOAA CIO Council made up of the CIOs from the different business units. So we, Weather Service, our satellite operations, National Marine Fisheries, National Ocean Service, they all have CIOs. And so we get together on a weekly basis and we'll make decisions, and a lot of it is based, as Jerry said, on risk, looking at how much risk we can tolerate in moving to new technologies. That's supported by IT committees. I think we have about 7 committees focused in different areas, such as messaging, networking, architecture, et cetera. But we've spent a lot of time on, in the last, say, 2 years, is on data management. And we have an environmental data management committee that we've completely revamped the policies, implementation directives, guidance, et cetera, focused on making the data as accessible and as independently understandable to the users as possible, so that we can get maximum use, and then also focusing on end-to-end life cycle management of the data. And then from the geospatial perspective, there's a federal geographic data committee, and that has the senior geospatial officials from the different departments that we get together typically on a quarterly basis. And then again, that's supported by different committees and working groups. So it's a fairly rigorous process.
Yeah. Nick, over EMC, I'm curious how you look forward to try to figure out, what do you do in terms of making a decision about which direction to go? Do you get input from the customer? Do you have researchers? Do you lab? You got people, or all the above?
I would say all the above. We stay very close to our customers. Working in my travels across the country, I've met most of the people here in this room, and many other CIOs. So we stay close to the customer to understand what's coming down the pipe. We also have a Congressional Affairs Office that stays close to the legislation. Right. EMC is also a member of Tech America CEO Council, so we work very closely with the administration on developing the new governance and discussing how that governance will affect the commercial industry and providing input. So.
Yeah, terrific. Gary, how about at Isilon? How do you, sort of like make decisions about products that you believe need to be brought to the market to support the customer? Do you get customer input or researchers, all the above?
We get a tremendous amount of input from our customers on what direction they're going and over what period of time. So as everybody has talked about, how do you manage risk? We try to reduce that risk and giving the customer a predictable model on how they can apply the storage solutions that Isilon provides in a timely and efficient, cost-effective manner. The other thing that's important is that the baseline of Isilon's technology is commercial off-the-shelf technology. So as Intel produces new chips, faster chips, as we get faster hard drives, bigger hard drives, those are easily inserted into the into our platform, right, and done in a timely manner. So when the 3 terabyte drives become available, we're delivering those immediately. When the 4 terabyte drives become available, we'll be delivering that. So our scale will go from 15 petabytes to 20 petabytes, right, literally the day that we announce.
Yeah, terrific. We've only got about 11 minutes left to the show now, so I'm going to shift to the future. We always like to end the show by talking about where this is all going. So I'm going to each of the panelists to kind of look into your crystal ball and predict the future here. And we'll work our way right down the table here. Let's start with Nick over at EMC. Nick, where's this all going in the future? Where do you see, out 5-10 years maybe? What kind of why will these technologies make a big difference?
Well, IT has to be flexible, dynamic, and efficient. The days of building monolithic, stovepipe silos of excellence are limited. We have to be able to move to developing rapid, flexible IT. One of the virtualization is one of the key technologies that will allow this tectonic shift. If you look at the telco industry or the power grid industry today, it doesn't matter whether you plug in a cell phone or a microwave oven. You get the power you need on demand, and then you pay for what you use at the end of the month. That will truly be IT in about 5 years, and virtualization will be that one of those capabilities that allows that change. But it's virtualization across the technology stack, the compute, the network, and storage. And that's where the industry will go to converged infrastructure stacks. In the past, building best of breed meant a lot of upfront time. Well, what you're going to see is industry coming together, working with best of breed and delivering pre-engineered solutions that allow the customers to rapidly implement these capabilities.
Okay, so terrific, very good, well put. I look forward. Marty RoesCH, what's your future look like, where these technologies are going?
Well, from our perspective, we need to shift the game if we're going to be competitive against the threats that we face. In order to do that, we really need to start integrating awareness about the environments that we're protecting and using that information to be able to tune and configure our security infrastructure in real time. At Sourcefire, we're starting to talk about this concept of information superiority, being able to synthesize large amounts of data about the environment that we're protecting in real time and turn that into real-time protection for the environment. So that you don't have a staff of people who operate on people timescales, right, trying to figure out how to configure the security infrastructure in the face of new threats. So that's really one of the biggest areas of focus that we have right now, bringing automation to the table that is driven by information superiority so that we can have effective capabilities in the face of modern threats.
Yeah, terrific. And we need to bring you back when we do the cybersecurity discussion sometime too, to drill down on some of these things. Frank Konieczny, what's the future look like for you? Where are these technologies driving you?
As the Air Force progresses down towards a single integrated network environment, which means that the aerial, the space, and the terrestrial layers are all connected together, you'll see virtualization probably at the aerial and space layer as well as large amounts of data being transmitted across everywhere. Now that provides a lot of security challenges, provides lots of capacity. I mean, we could probably use some storage arrays in the aerial layer, as well as some other layers that are compressed down to the size and that we actually need, because we talk about everything going down to the ground. Well, that's going to change. Everything has to be more dynamic, more to the needs of the mission right when the person needs it. And that plays into the mobility challenge as well, because as we come out with more devices, we have to be able to send the data to that device. And so what you're going to see somewhat is more of an IP cellular network in the sky, where we're all going to interlink with each other. But again, security, data, big data, quick response time, and the devices are all key essential elements that we are going to see in the future.
Yeah, I think the challenge is there for industry to stay ahead of the curve, because it's as we said here today, things are moving quickly. Gary Newgaard for Isilon, what's it look like in the future for you, Gary?
I think the most important element that we'll see over the course of the next few years is the concept that Nick talked about, the convergence of compute and network and storage into an easy turnkey solution that doesn't require a whole host of people to deploy. This concept of using an active-active directory that I can push data to the edge, to the warfighter, to get it there in a timely manner so that we can protect our nation, or we can react to the life sciences. It's all about how fast can you get the data there, sort through it, and provide it to the user. And that is really the most exciting part of what's going on, I think, over the next few years.
Yeah, that is exciting. Well put, well said. Appreciate that. Joe Klimavicz, what's it look like for you down the road where this is all going?
Well, I think today we talk a lot about shared services, and we do that interchangeably with centralization, consolidation, even outsourcing. But to me, true shared services, it represents more of a substantial change than these concepts. I think in 5 to 10 years, I think a lot of stuff that Nick talked about in terms of IT on demand across the entire compute stack will be reality, and we need to get to that point where compute, storage, networking on demand. And I think the federal CIOs are going to be pushed to the building real shared services to eliminate unnecessary duplication and to continue to improve delivery of services and be agile and responsive. And then also, I mean, most important thing is drive down cost.
Yeah, I know those shared services have been tough because there have been culture challenges to get agencies to share, but I think some of the tight budgets we're looking at now and some of the pressures to reduce costs are going to once again fuel people to really start thinking about ways to do a lot more sharing.
But I think in 5 to 10 years, it's going to be easier. The technology is going to, we could have done this 10, 20 years ago, but it was very difficult, and you didn't see a lot of it. I think in 5, 10 years it's going to be ubiquitous.
Yeah, well, I agree, and we've discussed quite a bit, the challenges with government-wide approaches and things like that, as well as the way the Hill is structured and the appropriations are structured is also another challenge, I think, that over time needs to be looked at how you can, share some, how you can't go with the pass-the-hat approach, to get money for a government-wide program. Jerry Davis, what's it look like in your future in terms of where is all these technologies going? What kind of a vision do you have for where it'll be in the future?
Right. So I kind of look at it from a business perspective. Security always seems to be, or has been for since the inception, the arch enemy of good business process. Right. So everybody wants to run their business. They want computing to be fast, accessible, and ready to go at the moment you push the button. Well, security has a tendency to impede that. So the technology we have to get to a point where security is adding value, right? So what I mean by that is that today we have entire programs, patching programs, and that always kind of boggled my mind that I spend a significant amount of my time patching systems,
right,
because of poor software development, right, things like that. Well, we're looking at 50 billion or so IP-enabled devices in the world. I can't manage 50 billion devices, and I can't patch fast enough on 50 billion
right
devices. So I think technology going forward, we're going to have to start seeing security embedded in devices themselves. So, and I believe that it's going to have to be embedded below the operating system, down at the silicon, at the chip level, where security is inherent and is providing those security functions for you. And I think we're going to start seeing that over the next 5 to 10 years, where machines are more self-aware and not just aware about the environment, but what's taking place from a security perspective. It's going to have to be built into these devices in the next 5 to 10 years, because you can't you keep up with the pace with the sheer number of devices that are coming out and the attacks and the nature of the attacks. It's going to have to happen at the device level. Device is going to have to give us some help.
Yeah, terrific. And I know on that security question, it was it's a tough issue because security costs you essentially in 3 ways. It costs you money, it costs performance issues, and it costs some user-friendliness issues. It's not as easy to go through the process. However, the argument has always been that if you do and are seen as having a secure environment, you'll be seen as a trusted enterprise and a more trusted partner. And I think that's another issue that everyone's facing with these technologies, is the ability to know who the trusted enterprises are and who your secure supply chain is and things like that. So there'll be challenges for all these technologies. Let me try to do a quick recap here. It's never easy to do, but I jot some notes down as we talk. The wireless issue came up again and again in terms of the challenges with wireless, the feeling that it is on a fast track, they're proliferating like crazy, but we're going to, and Jerry's comment, I thought you need to see it and you need to manage it, and that's going to be a challenge with the proliferation. We talked about the big data growth and 10 times data growth explosions happening and the need for big data, but not just the fact that we need to manage the big data, but we got to secure it. Becomes a big issue. And of course, getting into virtualized environments are going to help. And of course, that brings along then the visualization. If you can, in order to turn that big data into usable stuff, I think visualizing it is going to be a thing of the future. You know, Albert Einstein said, if you can't visualize it, you can't understand it. And I agree with that quote. I think, you know, I think the era of text is going to go away. I mean, I think in the future we're going to be doing things in much more visual format. Information is going to be visual. I even think requirements will be visualized. You know, if you think about IT, pretty much the only thing that you don't visualize before building is IT systems. So I think that's due to change too. I think, you know, these technologies, what I heard from everybody is there are opportunities for new capabilities. There's opportunities for consolidating and streamlining, improving business processes, and oh yeah, by the way, and reducing cost by getting rid of some of the older and harder to maintain O&M based systems we have out there today. So with that, I'd like to turn and thank our panelists from our experts from coming out and being with us on the show today and sharing your experiences and your knowledge with all of us.